So here is our process. Here's how things work the way we have architected too. So we have, as you can see, TMSM is the hub of everything, is the central hub of everything. So what happens is we've configured the process in a way that we send an event to TMSM, and then TMSM receives that event, processes that event, and then it does an action based on that, and based on that action, it triggers another action. So that's what this slide is about. But I know I just want you to take a peek into this before we come to this in detail. So the way we instrumented a process around this whole the TMSM and data mover process is by using control tables. So what we did was we put two control tables together. So as we understand, the data mover tool moves data from A to B, and it moves exactly what we tell it to move. It has no other intelligence behind it. So if we tell it to move the full table, it moves the full table. If we tell it to move based on a condition, it moves based on that condition. So there are two ways to do that, the conditional or the partial move. One is you can provide the condition as a string, or the other approach is it could be dynamic. So what the approach that we took was we took the dynamic approach. So because every night when we move data from A to B, we change what we move. We keep information about what we've moved and what we should move the next day. So what we did was we took this approach. Basically, this table has information about what database and table we've configured for data mover, and then every table that we need to move should have an audit column. The audit column provides us the capability of detecting what is the delta, what is available on system B, so that we can go back and find out what is loaded since then, and then move just that delta data. And then table sync status, it just tells us whether this table is in active sync mode or not. We can turn off and on a particular table if there are any problems, if we want to delay it. And then these update, last update, row count, update key, and observation start, timestamp, those are the audit columns that we use. Row count is the number of rows in the table. And then we've grouped those different tables in database and tables through as application grouping. I'll come to why we did that. And then and notification purposes, point of contact, email notification. And then we have a sync type. Is it a full table copy or a partial table copy? And then the audit timestamp the create date is more for our change control. When did we create this sync process? And audit timestamp is when did we actually last time we checked the status of this table? What is the current status of this table across the systems? So that's what this control table is about. So that's an explanation of that table. And there's another table called the job sync control table. So basically, one is for the to extract, to detect what we need to move and keep information about the table, right? This one is about the data mover job. What is the data mover job name for a particular database name, a table name combination. And we also have a column where we can set the priority of the table, then the direction. So we have like three production systems in our environment. So we move from A to B and B to C. And A and B are in Plano, and C is in Auburn Hills across the WAN. So the data mover job name, and then those three columns at the bottom are the ones that are very, very useful for us and from a reporting perspective. One is the job start time. When did the job start? When did the job end? Was the job successful? This is very crucial for us because it helps us understand whether the job succeeded. It helps us in putting an operational support plan together. And this is an explanation of what the table is about, and we've got some naming standards in place so that it's helpful for anyone to support the process. We use the source and target as P1 and P2, P2 to P1. That kind of defines P1. P2 is P1. It goes from P1 to P2. P2 to P1 is P. It goes from P2 to P1. P2 UAT. Sync type P and F. So this is the core script that we use to run the sync process. This is the script that would get executed if the table is not in sync. And this does everything from identifying what job needs to be run, what data needs to be extracted, and then after doing all of that, it keeps tab on what is the current status of the table, what is the number of rows in the table, and all that, the audit control columns. So there is another script that we put together. This is called the data mover sync gather update stats. So basically what this script does is it gathers information about the table. So for example, if we take a table and that is supposed to be synchronized across 3 systems, what happens is the data mover moves the data from system A to system B, and then system B to system C. And after the whole daisy chain completes, this script gets triggered off, and what it does is it goes through all 3 systems, gets information about the row count and the max of last update timestamp. That's the audit column that we use predominantly. So it gets that information and updates the control table, so we know exactly what is the status of a particular table at any given point in time. We have another script, so we have information about the table itself. Then this script, what the data mover sync update job status script, what that does is we kind of hook into the data mover repository to understand the data mover job for a particular table. When did it start? When did it complete? What is the status? And we gather information so that we can report on, okay, the table is in sync, but when did the job start and when did it complete? What is the status on that? So all of this helps us to provide rich reporting capability on top of the sync process. So to go through this slide, now that we understand a little bit about the different components in the scripts, what happens is in the data mover server, we can trigger the data mover jobs in multiple ways. One is it could be time-based, it could be event-based, and event-based could be 2 ways. One is you can just do a send event. The other one is it could get integrated with the ETL process, so when ETL completes for a set of jobs, it can trigger the event to TMSM. So what happens here is basically the event is sent to TMSM. So in TMSM, what we've done is we've taken the table and then grouped the tables together as application grouping. So for example, we do claims. So we've grouped all the tables that belong to the claim process and call them an application group by name claims. So it has a set of, say, 15 tables to it. So when we send an event to TMSM saying, hey, go check the claims application group, what TMSM does is it'll go in and go across the systems, say for example P1 and P2 system, and looks at those 2 systems for that particular set of tables and does either a row count or a checksum, which is not available anymore, and we can do...
Actually it is.
Yeah, we used to do that. We changed it to there's more flexibility now where we can write our own SQL. So we've leveraged that feature. So it'll use that to go check if the tables are in sync or not. If it is in sync, then it does nothing, comes out with a exit code, and if it is not in sync, then it raises an alert, and that alert we have. So the alert threshold, if it is above what we've got configured, it causes an action, and that action is to actually execute a script remotely on the data mover server. And the crucial thing is TMSM detecting how the tables are in sync or not, and there are ways to do that, and there's a lot of advancement in that space. Want to speak to that?
Sure. Well, that's been evolving in Ecosystem Manager, but the current state of it is you can issue, like Abraham said, off of an event or off of a schedule, run a validation of one or a set of tables, any number of tables. And what that'll do is it'll run in parallel using multi-statement requests and multiple sessions on each of the systems, it'll go and run validation scripts, which are row counts, which can be partial row counts, because you can also specify where clause there, so you don't have to go scan the whole table. Partial row counts or partial checksums. What I mean by a checksum is any expression that's an aggregate expression that covers all of the rows in the conditional, depending on the condition that you've specified. So it'll do the same SQL on different systems and determine, based on the metrics that are resulting from the SQL, whether they are in sync or not. Right? Compares those metrics. If the metrics are not in sync, it raises alerts, and you can act on those alerts, which is what you're doing now.
Yep. Yeah. Excellent. So some of the things that, from a database management perspective, we want to watch for is those are SQL statements. So when we run the when you do workload management, we got to make sure that those kind of get in and out quickly, because we don't want them to be sitting on one system for a long time and the other system it's completed. So those are the little bit things that you need to watch out for. So what happens after that is when the action is triggered, the external script is so the action could be many things. What we chose to do is execute an external script on the data mover server. So it makes a remote call into the data mover server. And then in the data mover server, the DM sync table script gets called and that runs. So that script is a generic script, right? So it doesn't understand anything about what table or what database it needs to work on. So the additional advantage of TMSM is it's parameter driven. So you can pass parameters along with the script. So we pass parameters like the TDP ID, the database name, the table name, and the alert code message. And the script in the data mover server, the one over there, what it does is it parses all those parameters and leverages those parameters, and then runs the script, the sync process for that particular table name database combination. So even though we do application level grouping and triggering the event so it goes and checks, when the action is invoked, it is at the table level. So that's the added advantage of what we've done here. So the data move process runs, the parameters are parsed, the data move, it extracts the information about the table name and database name, so what data mover scripts needs to be run, it gets all that information, and the data mover job itself is executed. So the way we've got it architected is we have the data, the data will go from P1 to P2, which is in the local data center. So we'll dive into that a little bit. And we were using our corporate network, and we were really pushing our network very hard. So we started to get a lot of calls from our network team. So we started looking into how can we mitigate that situation. So we looked into options, worked with Teradata, and came up with a solution where if we can dedicate a network path between the data mover server and the Teradata systems, we will isolate that data flow and mitigate our risk to the corporate network. In addition to that, the additional benefit that we get is because we move close to about 700 tables, and to that point, not all 700 tables will be replicated every night. The TMSM identifies which of those 700 tables need to be synchronized, right? So out of the 700 tables, maybe about 150 to 175 tables on an average in a day would have to be moved every night. And of those 175 tables, 90% of these tables might be full table copies, because these might be domain tables, right? So we want those to be full table copies. So the large fact tables, we don't want that to be a full table copy. So yet we still move close to about 500 gig plus data nightly, and that is what was causing our network contention. So we had to go to the solution of having dedicated hardware. So what we did was